Assalamualaikum warahmatullahi wabarakatuh. So we have met again in this video where I will explain to you on the law of total probability. Okay, this is nothing new, but we just want to focus on the law of total probability. The total here means we have a set of non-mutually exclusive, set A and set B, but now we want to focus to find only PA. Okay, probability of event A. So the formula is PA intersect B. Let me draw to you here. So the formula is PA intersect B, this part here, and we need to add it with this part here, PA intersect B complement. So where is B? This is B. So B complement is everything outside B, and let's intersect B complement with A. So if I draw it, this is the part here where this is B complement intersect A. So if we add both of them, therefore we will get the law of total probability PA, the whole thing here. Okay, that is by looking at the Venn diagram. We can also use the law of total probability by using a tree diagram. Okay, so let me demo to you from this example here, example 43. Let's see example 43 here. This is the perfect demo for the law of total probability. The probability that Amy leaves early for work, let's look at the keyword early here, is 0.67. This is the first part of tree diagram here, where we'll cover Amy is early and Amy is late. Okay, so let's denote E as early, E prime as late. The probability of Amy will be early is 0.67. So the complement 1 minus 0.67 is 0.33. Therefore, the probability Amy will be late is 0.33. Let's read further. The probability that Amy gets a parking spot at a covered area if she leaves early. This is very important. The probability that Amy gets a parking spot at covered area if she leaves early. Meaning that this is the second part of your tree diagram here. Okay, where you'll have a covered, uncovered, and also this is for early, and also for when it's late, we'll get covered and also uncovered. I've named here C for covered and C prime for not covered. What's the meaning of this probability here? This is the probability of getting a covered area if she leaves early. So it's written there that the value here is 0.85. So let's write here as 0.85. Therefore, we can calculate ourselves this branch here. This is the probability of Amy get uncovered parking if she leaves early. So we just take 1 minus with this 0.85. So it is 0.15. Let us read further here. The probability that Amy gets a parking spot at the covered area if she leaves late. Okay, so the probability that she'll get parking spot at covered area if she leaves late, it is 0.15. So this is this part here where she will get the covered area if given she is late. All right, so just right here, probability of covered if late, this is 0.15, and we can calculate another branch here, which is just the complement 1 minus 0.15. So it is probability of getting not covered if she is late, so it's just 0.85. So I finish with the tree diagram here. So this tree diagram is for the conditional probability of Amy late or early, and she will get a covered parking spot or uncovered. Let us read what does the question wants. Okay, so the question wants find the probability that she'll get a parking spot at a covered area. So it is clear to us that the question wants PC. We have two ways on how to solve this question. Okay, we can use the formula of law of total probability that we have just covered just now, or we can use the tree diagram. For me personally, I like to use the tree diagram because it's easier, but let me just show you both ways so that you can decide by yourself which one you prefer to use. Okay, so let's use the theory as what we have learned before. Okay, so we want to find PC, probability of covered area. However, I will see here the covered parking area depending on the previous event, which is early or late. So if you want to use this law here, the law of total probability, it will be PC intersect E plus PC intersect E prime, because our C now is depending to other variable. Okay, so our C is depending on early or it is depending on late. The next step is just open up the formula. PC intersect E is just PC given E times PE. So just open up PC intersect E prime. It is PC given E prime times PE prime. So let's just take the value here. PC given E 0.85 times PE, which is 0.67, and add them up with PC given E prime, which is this number here, 0.15 times with PE prime, which is 0.33. So just use your calculator, you'll get the answer 0.619. This is by using the formula. However, if you want to use the tree diagram, it's very easy. Let me show you how to do it. So the way to do it is we want to find PC, right? So we know that our C is here and both of them are depending on the previous event. So if you want to find PC, which is law of total probability, so it is very easy. Just multiply the branch together. This is the first branch and this is the second branch. Okay, multiply them together and add them up. This is the same with what we have done just now. So multiply the first branch, 0.85 times 0.67, plus multiply the second branch, 0.15 times 0.33. So you'll get the same answer, 0.619. So if we use these branches here, it is easier rather than we use the formula. Because for the formula, we need to write this formula and we need to open up the formula like this.